In this video, we're going to continue our discussion of 5.2 and 5.3 by first of all reviewing solving a system by both substitution and addition. So we should get the same answer either way. Here's our system. If we want to solve using substitution first, take a look. Let's see, here's an x value that's easy to solve for. So I'm going to have 2x, leave the first equation the same, and I'm going to solve the second equation for x. Then take our x value, 3y plus 6, and substitute it into the first equation. And the goal is to get an equation with one variable. Now we can solve our equation for y. Add like terms. Subtract 12 from each side. Divide both sides by 9. We get a y value of -1. Now we need to take that and substitute it back in to our equation we solve for x to figure out what the x value is. So we end up with x equals -3 plus 6. So this has one solution, the coordinate 3, -1 if we were to graph it. Now just a little practice, solve by addition. So now we take a look, notice that the positive 3y and -3y will already cancel when we add them together, so we don't have to multiply by anything. We get 2x plus 3y is equal to 3, and x minus 3y is equal to 6. Add the two equations together, we end up with 3x, the y coordinate cancels each other out, is equal to 9. Divide by 3, x is equal to 3, so that checks with what we got in the first method. Now take our answer of 3 and substitute it back in one of the equations. I'm going to go ahead and use the second one. 3 minus 3y is equal to 6. Add 3 to both, or subtract 3 from both sides. I get -3. Y is equal to 3. Divide both sides by -3. And y is equal to -1. Okay, so that kind of checked for us that we got the same answer either way. So that was just some extra practice. Now notice the two problems we've done so far in notes had a solution. This means that the graphs intersect at one point and the system can be solved for x and y, but that doesn't always happen. So the next part of notes is what types of solutions are possible? Okay? So it could happen that we get an inconsistent solution or no solution, where the lines are parallel and they never intersect. The system itself can't be solved and results in a false statement such as 4 equals 0. So if you look at the lines or the system that we have here, x equals 2y plus 6 and 6y equals 3x minus 6, writing each of those in slope-intercept form, they have a slope of a half. And if you look at the graph, they never intersect. So there's no solution or it's inconsistent. If you were going to solve this algebraically, it's set up for substitution. Let's see what happens algebraically. I'm going to take that 2y plus 6 and substitute it in for x. So I get 6y is equal to 3 times 2y plus 6 minus 6. End up with 6y is equal to 2 times 3 is 6y. 3 times 6 is plus 18 minus 6. Now when I subtract 6y from each side, I get a 0 equals 18. 0 is equal to 12. The variables cancel each other out, and I'm left with a false statement. That's what tells you algebraically without graphing that the solution is inconsistent. Next type of solution that could happen is something called dependent system, where we get an infinite number of solutions. So the lines coincide or they're the same line. The system can't be solved and results in a true statement such as 0 equals 0. If you take a look at the two equations we have here, if you solve them both for y, both of them end up being y equals 1/3 x minus 3. They're multiples of the same line. So when you graph them, one is just graphed on top of the other. What this looks like if we were to solve it by elimination, let's see, if we eliminate x's, I'll multiply the top equation by 2 I end up with 2x minus 6y is equal to 18. And you'll notice when you take a look at the bottom equation, negative 2x plus 6y equals negative 18. When you add these together, everything cancels and you get 0 equals 0. That tells you one line is the same as the other, it's just a multiple. So those are called dependent. So that means that every single xy that works in one equation is going to work in the other equation. So there's really an infinite solution, number of solutions. All right, number 7, solve the system by the method of your choice. If there's no solution or an infinite number, so state. Use set notation to express solution sets. So looking at that, it looks like substitution would be really hard to do because there's not anything that you can multiply by easily or solve easily. So let's solve the system by elimination. So you choose one or the other. I'm going to choose y's because I have one positive and one negative, and when they add, they're going to cancel. And think of it as common denominators. What do 5 and 6 both go into? 30, right? So I'm going to multiply the top equation by 6 and the bottom equation by 5 so that when I add them together, the y's will cancel. So I get 7x times 6 is 42x plus 5 times 6 is 30y is equal to negative 13 times 6, which is 78. Bottom equation, we're going to multiply by 5. I get 5 times 5 is 25x minus 30y is equal to 29 times 5, which equals 145. Add the two equations together. We know our y's will cancel. We set it up that way. We end up with 67x is equal to 145 minus 78 happens to be 67, so that looked like it might be a difficult fraction solution, but we ended up with 67x equals 67, so x is equal to 1. Now we take our 1 and substitute it back in one of the two equations. I'll just take the top one because it's close. Okay, we get 7 plus 5y equals negative 13. Subtract 7 from each side. 5y is equal to negative 20. Divide both sides by 5. Y is equal to negative 4. So this has one solution, and the solution set is the coordinate 1, negative 4. All right, last example is in a word problem. What types of word problems result in systems of equations? And if you've done these ever before, usually it's something called a mixture problem. Okay, in this case, this one is the ticket problem. There were 565 tickets purchased for a Major League Baseball game. The lower box tickets cost $12.50 and the upper box tickets cost $10. The total amount of money spent was $6,285. How many of each kind of ticket were purchased? So how do you recognize this is a system of equations? Well, you've got two pieces of information. One is number of tickets that you sold, total. And the other piece of information you've got is the total dollars spent. So we're going to write one equation that has to do with number of tickets and one equation that has to do with dollars spent. We just need to identify some variables. You can use X and Y. You can use L for lower box. So I'm going to use L as the number of tickets for the lower box. Okay, and the upper box, U, I'm going to use as number of tickets for the upper box. So when we talk about our equations, two equations, one of them has to do with the number of tickets. I know total there are 565. So lower plus upper equals 565. So that's how one equation. The second is, I know total amount of money, $6,285. So now I go back, Well, if I have lower tickets, how much do they cost? The lower box tickets cost $12.50. So those are going to be total $12.50 times all the lower box tickets is total amount of money. Then upper box, $10 each. So 10 times the number of tickets is the total amount of money spent on the upper. So this is our system of equations. So now next step, solve by substitution or elimination. It looks like it either way is about the same amount of work. I'm going to use elimination and multiply the top equation by 10. And I want it to cancel with this positive 10, so I better multiply it by negative 10. So I end up with 10, negative 10L minus 10 times U is equal to negative 5650. Bottom equation stays the same. Add these two together. U eliminates, and I'm left with $2.50 times L is equal to 62.85 minus 56.50. Which I get is 635. Divide both sides by 2.5. And we end up with 254 for L. So there were 254 lower box tickets. Then to figure out how many upper box tickets, I've got my ticket formula. L plus U equals 565. So let's put 254 in there for L. Subtract 254 from each side. I end up with 311 upper box tickets. And you can check that to see if the cost comes out how it should. 254 times 1250 plus 311 times 10. And if all goes well, that equals 62.85. Just checking on the calculator. Okay, it works. So we sold 254 lower and 311 upper box tickets.